Well, it's 1 p.m. Hello, folks. We're going to get started. My name is David Witt, and I am CFO at Salinas Technologies. I'd like to thank everyone for joining us today for the SonicFinder 1000 webinar. We have 45 minutes allocated, so we will move along promptly, but there will be an opportunity to have your questions answered following a brief technical presentation and 3 case study snapshots. If you do have questions, please enter them in the box at the bottom of your screen on the right-hand side, immediately adjacent to the chat box. For those of you who don't know Salinas, we are a Canadian technology company specialized in the detection and identification of underground infrastructure. Next slide, please. We are pleased to be represented by the leading North American resellers in the market: Eastcom & Associates, Green Equipment, Subsurface, Batco, and Southwest Valve. Speaking today will be Mark Bracken, our founder and CEO, and Brad Horton, our VP Sales and the co-inventor of the SonicFinder 1000. With that, I'll turn the presentation over to Mark.
Thanks, Dave. So if you're on the call today, then chances are you're fully aware of the issues around unlocatable non-metallic pipe. There have been several promising technologies that have been released over the last, say, 10, 15 years, and none of these have solved the problem. In contrast, our SonicFinder 1000 is the first new product that is truly gaining widespread acceptance in the market, and for good reason. Our new device has been very successful locating utilities that otherwise would have had to be excavated. On the webinar today, you're going to get a very good introduction to the theory and use of the instrument, as Dave said, along with some case studies. I like to go through how the SonicFinder works, and it's actually very simple. Many of you will be familiar with hydrant-mounted pipe locators, which create noise, which carries through to the pipe, and then you try and follow it with a ground microphone. Our device works in exactly the opposite way. We induce sound waves into the ground through an actuator shown in the photograph on the left, and there is a receiving sensor that sends the signal back to the control box on the actuator. The sensor is shown being mounted on the right. The control box shows the level of vibration induced in the pipe, and very simply, when the locating device is directly above the pipe, the acoustic sensor sees a maximum. You can see on the right-hand side that we need access to an appurtenance or a location directly mounted to the pipe. In this case, the sensor is being mounted on locking pliers attached just below the gas meter. So to summarize, to use the SonicFinder, you locate a mounting pipe connected to the pipeline. The locator then takes the device after the sensor is mounted and moves it back and forth in a perpendicular direction to where the pipeline is. The pipeline then is marked as you would be for any locate with either paint or flags. So this slide just goes a little bit more graphically. You can see our cartoon locator moving back and forth across the pipe, both with one sensor located on a fire hydrant, the other on a gas valve. The operator moves back and forth again until the unit finds a maximum level, places the flag, and then proceeds down the presumed direction of the pipeline travel. So a little more detail for those interested in the background theory of the technology. The actuator, as mentioned already, sends acoustic vibration waves into the soil, which impact the pipe. Technically, the actuator produces a compression wave, which in the world of vibration, we know as a P wave. That P wave then travels as a compression wave through the soil, hits the pipe, and then the sound wave is traveling both in the wall of the pipe and in the fluid inside the pipe. In case of the water, it's the same type of wave that we use for leak detection, where it's a combined wave between the wall of the pipe and the water. And in the case of gas pipe, the wave travels primarily through the gas inside the pipe to the sensor. Because we're inducing this compression wave in the soil is actually very poor at transmitting shear waves. So it stays in a very narrow core of vibration. So when we do these locates, they can actually be incredibly accurate. I'm going to put it over to Brad Horton to go through some of our advantages, the use of the equipment, and our case studies. Brad?
Thanks, Mark. Morning, everybody, or afternoon, depending on where you're at. The SonicFinder works in a lot of different soils. Actually, work in any soil type. The general rule of thumb is the more dense the soil and compact the soil, the more energy you're going to have transfer through the soil onto the pipe. So basically, we love what GPR hates. The more dense, moist, compact the soil, the happier we are going to be with the results. It will work in sand. We have different spikes which we'll go through. So we do have different accessories that will allow you to locate in sand or soft soils, as well as underneath asphalt, concrete, that sort of thing. Next slide, Mark. All right. Now, the user interface of this is really simple. Looking at the screen, you see the large numbers there in the middle. That is your signal strength, or actually your amplitude of sound in our case. There are some other icons on there. It gives you a real-time sound reading, so you know what your floor noise level is. There's a histogram, which records the last 3 peaks or numbers that you got on the instruments, so you can track it well, and you don't have to keep the numbers in your head. Again, user interface, up and down membrane switches to control the gain, to control the frequency, to change the frequency. Across the top, there's some icons with the timestamp. G for GPS. That is not survey grade GPS. That's I'm in the right county GPS. As well as a radio link, which will be a white R on a black box with some bars next to it, as well as the battery life for the unit. Next slide, Mark. The menu, really easy. The one that you're going to use the most often is the very top, which is frequency scan. We do a frequency scan at each location until you learn your territory, and then you can, you kind of know which frequencies work best. But initially, you're going to start out, first thing you're going to do is a frequency scan, and it's going to tell you the top 3 frequencies, as well as give you a graph that displays the results for the entire frequency spectrum that we use from 50 to 200 hertz. And then it's simple just to back out of it, set your frequency, and go right on. Next slide, Mark. All right. When we're out in the field, you can see the graphic sort of the bottom right on the left-hand side of the screen. That is your frequency scan results. You see on this one, it says your peak frequencies are 75, 90, and 100. And then it's got the graph display right above it to, kind of correlate with that. Really good to kind of pay attention where your results are in there, so that if you need to go up in frequency to avoid, tree roots or catch basins, that kind of thing, you kind of know the results that you're going to get beforehand. Like I said, the frequency scan takes 3 minutes, 3.5 minutes to run. Crucial when you're out at the first location. Once you've done the same address or the same street several times, you'll kind of know what frequencies work best and be able to go to those. Next screen, Mark. We have different spikes. The 3 short stubby spikes we use on hard pack, concrete, asphalt, really hard pack soil that you can't get the 4 or 7 inch spike in. I'm probably using the 4-inch spike 90% of the time, 95% of the time. Works great in clay soils, dense compact soils. The larger spike at the bottom, again, that's for use in sand, gumbo, really swampy areas where you want a little bit more penetration and a little bit more oomph on it. So, next slide, Mark. We released actually started releasing product in November of 2024. We really started actually getting product in the field in the spring of 25. So just over a year in the field. And we have a number of adoptees. The list over there is obviously a partial list. A lot of municipalities, probably 80% of our business thus far has been to city of, town of, village of for their water and sewer lines. But we also have some fairly significant gas customers that are using it. Great tool if you've got a fiber crew coming through your town and they're boring and you've got a bunch of service lines that don't have tracer wire. This is a very expeditious way to get those lines marked out. Next slide, Mark. We're going to talk about a couple of case studies. Case in point, the first one, this was a 120-foot long gas service line that the wire was broken. They had no way to locate it. So they rolled as pretty crucial locate. They needed to make a new tap. So they dug out, they found the main, and they were chasing the main to the east. They had a hole excavated about 12 foot long, 5 foot wide, 5 foot deep, just chasing main. I happened by, didn't really know what was going on, but they asked me if I could locate that service line. I did. It was about 1.5 foot outside of their hole to the west, and they were digging east. We had four gas company guys there, a deuce snap dump with a low boy on the back of it, a tractor or a backhoe rather, plus traffic control. They had an outside contractor traffic control, probably a $25,000 hole that they had dug. Had some lanes of traffic shut down, the whole 9 yards. So had they had our unit, it would have been 2 guys and a shovel, and been a $3,000 or $4,000 hole, not a $25,000 hole. Next slide, Mark. Gallia County, Ohio was one of our early adopters, the rural water down there. They have surgical soil conditions. It's all densely packed Miami and clay, Ohio River Valley, bottomland, moisture. The locator down there is just knocking it out of the park. I told him when we first started, he'd probably get a couple 100 feet per locate. He called me back several weeks later and said I was a liar, that he's getting, 500-600 feet when needed at a locate. I think the longest one he did was 685 feet of 4-inch main, and he knew he was on it because he got to a T, a valve at a T. So he really has had a lot of success for this. Now the picture that you see up there, that's actually a hydro excavation mark, and that little white square over to the right of the vac truck snout is actually the water line that runs up this road. As you can see, it's a pretty crowded area. You've got a fiber splice pit that gentleman's standing on, so you got fiber lines running through there, interduct, and we were spot on, maybe 3 inches off on all that. So pretty accurate piece of equipment. Next slide, Mark. This is one, I wasn't at this one. This was done a couple of weeks ago, but interesting in that this was a 40-inch concrete water trunk main that these guys really, they've got access points, are kind of scattered out a bit. And they know generally where it's at till it turns off the road, and then it gets kind of lost a bit. So, people ask how big a pipe will it work on. Well, this is actually the biggest pipe we've done so far, 40-inch. It will probably work in larger diameters. You do lose a little bit of distance once you go up in diameter, but we're talking about losing a few feet, per 2-inch increase in ID of the pipe. So, but really just a great result. This is soil GPR does not work in, so not an option for them to use GPR carts. But it was successful, and they were able to spot this line out. I think they went about 200 feet on this before they had to probe down, hit the crown of the pipe, move the sensor over to the probe, and then able to continue on. So, yeah.
And
Next
that
slide,
was
Mark.
Clovis, California, Brad.
Yes.
Ken
Yeah,
got back
yeah.
to me with the utility name.
Yeah, Clovis, California. Yeah. So anyway, next slide, Mark. These are just a few other success stories that we've had. I'm not going to go through them individually. You can just see everybody kind of gathered around, and the one there, the second one from the left, you see the pipe down at the bottom of the hole. So again, since March of 24, or excuse me, 25, really had quite a few adopters, and again, most of the folks are just absolutely singing its praises. Cutting so much time down. We've got a gentleman we sold one of the first units to in Australia, and he figures it's cutting about 30 or 40% of his time, because what he was doing before, he was just having to hydro excavate to find services, and sucking a hole or two or three per yard. And with this, he goes in, he locates it, he sucks down, he finds it, measures the depth, drops a marker ball in, and away it goes. So he figures about 30-40% time saving for his project. With that kind of covers the case studies and the stuff we're seeing in the field. We get to the best part of this presentation, and that is the product questions. So Dave, if you got anybody that's got a question, let me know.
Absolutely. We've got a couple so far, Brad. The first one is how deep can a pipe be found?
Yep, great question. Get it all the time. We just had a gentleman reported in that he found a service line, that 3/4 inch water line, 15 feet deep. I don't know how deep it will go. I do know I've spent a lot of time testing this in northern climes where every pipe is buried at least 3 meters, 10 feet deep, and we've been consistently successful. I don't honestly know how deep it will go. I'm sure there's a lot of variation there depending upon soil type and. So that's, I don't have a specific answer, but that's the best answer I can give you.
Great. And a related question, Brad, can you measure the depth of cover with this equipment?
We cannot.
Location?
Yeah, we have no way to be able to determine depth currently. It's engineering, and I can tell you that our engineers are trying to work on some machine learning and algorithms that will hopefully in the future be able to provide us with depth.
Great, thank you. Next question, is there signal bleed over to other utilities?
So again, great question. What you'll find is if there is some commonality, and the one that springs to mind to me always is water services going into a house or building, and then the gas service is mounted, the meters mounted to the side of the foundation. Where the water line goes into the house, if it's touching the foundation wall and the gas meter is mounted to the foundation wall, you can get some energy if you're doing the water over on the gas or doing the gas over on the water, because of that commonality of where they come through the foundation. Those are pretty easy. Obviously, the gas is going to go to the gas meter that's mounted to the outside of the wall, and the water's probably going to go up somewhere in the middle of the footprint of the foundation. I have had it where a French drain was laying on top of a service, and that French drain picked up some of the energy, and you could locate the French drain over to where it came down at the corner of the house. Again, pretty easy to tell it was a French drain because I walked right to the French drain. You can light up like sanitary and storm sewer lines a bit at lower frequencies. But for most of the quote unquote bleed over, just bump it up in frequency a little bit's gonna take care of any issues like that, Chad.
Very good. And here's a question we like. Can we demo the product if needed?
That's I am sitting in a car in Houston, Texas right now, and I've been demoing the product down here for a couple days. So that's a yes.
Excellent. And how effective is the equipment in areas with minus 30 degrees Celsius conditions with utilities below frost point of about 10 feet or more?
So again, we've located a lot of lines 10 feet deep. Frost is actually our friend. It makes the ground more dense, which it carries more energy. So I'm going to say the general answer to that is yes, we can. Um, Again, the best thing to do is to get a demo of the unit. And I love cold weather. It's 90 in Houston right now, and I'm miserable. So yeah, be happy to come up there.
And I will say that the device was developed in Calgary, Alberta, and the winters in Calgary can be very harsh.
But it was originally started in northern Michigan. So yeah, we started out on water testing on water lines 6, 7, 8 feet deep, and then when we moved testing to Canada, it's been 10 feet plus ever since, and we've been successful. So.
And Mark, maybe you can quickly discuss your experience with Saskatchewan parks.
Sure. Yeah, we had a very good demo with Saskatchewan parks, and they'll get down easily to -30. So yeah, we've got lots of experience in harsh climates as well, and we just got a purchase order actually from Saskatchewan parks to locate their water mains and water services.
Thank you. Next question. Will signal carry through a fitting, such as a curb box, and will it also carry onto a main from a service?
Yes to both of those. Every time it goes through a 90, you're going to lose a little bit of revolution of resolution. That said, service to mains are no problem at all. We do them all day, every day, where you locate that. Even that 120-foot service on gas for the one case study, I was able to locate 120 feet to the main and then probably 40, 50 feet both directions. I could have gone farther, didn't turn up the game, didn't need to. But yes, as far as fittings go, um, the only time that I've ever been like really defeated was I was on the wrong side of a backflow preventer. And because of the 490s and the check valve in there, I wasn't getting anything through that. That said, it'll go through a couple of 90s, it'll go through fittings. Check valves are a little tougher just because of their nature. So, but otherwise, yeah, gates, butterflies, that kind of thing. Obviously, unions, yeah, it's going to flow right through it.
Okay. Are valve wrenches recommended to clamp the microphone for locating water lines?
Yeah, so I've used valve keys a bunch. Obviously, the best way is if you can get the geophone down onto the operating nut directly. Now, this does have a magnet on the bottom of it, so going down ductile iron valve sleeves can be a little problematic if your arms aren't 6 feet long and your pipe's 6 feet deep. But a 2-inch piece of PVC on top of the operating nut, slide the sensor down the PVC to keep it off the ductile iron valve sleeve walls, and you're fine. And that part of the unit is completely waterproof. So if if your operating nut's submerged 2 or 3 feet deep, that's not an issue. You can use the valve keys. Back to the original question, you can use the valve key. You just have to watch for wind noise and things like that. But again, there's a display on the front that gives you your noise level without it being actuated. And as long as you're 6 to 10 dB above that, you're fine.
Very good. How does it work on AC water main and C900 water main?
Really well. AC, the signal bounces off the walls. So the more, stiff the pipe, the better the bounce. We've had zero issues with AC other than, if they're buried in the street traffic, control, that kind of thing. But yeah, it'll locate AC. It'll locate any kind of pipe. Obviously, EM is better for electromagnetic locating, is better for a lot of pipe types. But yeah, it'll locate any of them.
And I think our case study was C900. I'm not sure what the 42-inch concrete pipe. It was probably either C305 or C900. So it's either bar wrapped or PCCP, but it works. It'll work great on those big concrete pipes. They're just like big drums.
Good, good. We've got a couple of some other questions that have come in on the chat. Brad, what about plastic farm tile?
Gonna say we haven't done it yet. Theoretically, I mean, we've done French drain, we've done, all kinds of drain tiles in different applications, but actually big corrugated farm field tile, we have not done yet. I can't imagine that you wouldn't be successful locating it. Appurtenance, a place to connect to it is probably the biggest challenge there. So, but if you can probe part of it and get the probe rod down on the crown of the pipe, get a good starting point, then it should locate fine theoretically, but we haven't done any.
And will it locate PVC lines?
Yes. Yeah.
And then a follow-on question from Eric in the Dallas-Fort Worth area. Will it work in the types of soil that they have down in that area?
I will be in Dallas in a few weeks. I've already done a couple of tours down through here. Like I said, I'm in north of Houston. I'm actually in Huntsville, Texas right now. And yeah, it works.
Okay. And from Scott, do you have to be connected conductively to the line that you are locating?
For best result, yes. You want that sensor on an appurtenance attached to the pipe somewhere. Like I said, you can use a probe rod and, tap down to the crown of the pipe and use that as your contact point, but you are going to lose, I don't know how much, but you're going to lose some distance ability by that weak of a connection point. So if you can get to a meter set and get on the meter yoke, again, inline valve, hydrant valve for gas meter or inline valve, you're going to get far better results.
And just to be clear, we're talking it needs to be acoustically conductive, not electrically conductive.
Correct. Yeah.
Yes. Yes. And if you had a horizontal pipe going into the house, water pipe, Brad, how would you handle that?
For attachment, I take my vice grips and I clamp it onto there and I stick them on the adjustment screw on the end of the vice grips so that it's straight up and down. We actually got a picture the other day from a guy that he exposed the pipe and put his vice grips on the pipe and then zip tied his vice grips to the pipe, which above and beyond, but he said it worked great. He went about 300 feet. So yeah.
Good, good.
Whatever you can do. Back in our leak detecting days, we used to cheat a little bit. We would take a 1-inch square metal coupon, just a little flat piece of metal, 1-inch square, put a drop of super glue on it and stick it on the pipe and then attach the sensor to that coupon once the glue had dried it up. So any way for you to get good, solid connection to that horizontal pipe.
Very good. Very good. And there's a question on price, and I can answer that one. The price through our resellers is $9,200 US. And let me just see what else we've got come in here. If I were to need to find services for a house like water, sanitary, and storm, what would be the connection point?
Okay, for water, if you're in the southern part and have outside meter pits, that's a great place to start for the water. In the northern climes, if you can gain access to the basement or wherever the line comes in, the radios will work through walls. A lot of our testing I did on my geothermal line, so I had the sensor in my basement doing the testing. For sewer, it's going to be your clean out. You got to clean out outside. Just get on top of that nut, put a clamp on it, some metal on it, so you got something to stick to on the nut at the clean out. Just any appurtenance of the pipe, any contact point. Again, for the gas, you got the meter riser. For outside meters, I don't think there are any inside gas meters anymore. They figured out that was bad. So yeah, but just any access point.
Okay. Do you use any coupling liquid between the sensor and the pipe, or is it directly connected?
Directly connected.
Very good. Just repeat a question from Dustin. The price is $9,200 US. And from Jason, I have a project needing to locate 1,400 linear feet of PVC water main without tracer wire. Only connections are at one end, a series of valves and a hydrant. How far one direction can I expect to get results on?
So again, a lot of that comes to soil type, Dustin. So if you want to send a follow up to that, but in general, clay, again, dense clay is going to be your best conductor, depending on the diameter of the pipe, that sort of thing. 300-400 feet is not uncommon. Even farther in clay, if you're at 8,700 feet in the Sandina Mountains outside Albuquerque, New Mexico, you're probably going to get 150 to 170, maybe 200 feet max per hookup. But so much of that just depends on the dirt.
And again, Brad, it's worth mentioning what we've had people do is go that far, excavate down to the pipe, and then create another location to put the sensor on and continue from there.
Yep.
Great. And Jason's actually asking that question. He's in just west of Springfield, Illinois.
Springfield, Illinois is going to be clay, so you should get. And if you're in a rural area without a lot of noise stuff around and can really utilize the gain, you could get up to probably 500 feet on that if the gods are smiling on you.
And then Mark, to your point, after when you run out of range, if and when you run out of range, you can expose the pipe and reset the geophone and continue on.
Yeah, you'll have to create a connection point, Dave. So you'll need to get the sensor firmly on the pipe somehow. But
you can even take a probe rod at your last good location and get that probe rod down on the crown of the pipe. And again, if you're in a more rural setting where you're not dealing with a bunch of other stuff, you can then attach the sensor to the probe rod, the geophone to the probe rod, and be able to locate 150 feet or so on, and just kind of keep leapfrogging like that. Locate 150 feet, move your probe rod up, probe the crown of the pipe again, and go on.
Yeah, and I've also seen people use vacuum excavate down and just put a valve key down on as a probe rod. You can mount on top of that.
Yep. Good. Covered this a little bit, but how will it perform on 36 to 96 inch water lines? RCCP, steel, and PVC.
Yep. The biggest one we've done so far is the 40 inch. I personally did a 36 inch. And we're getting, 150 feet or so on that, maybe closer to 200. I think the one in Clovis that Ken just did on the 40 inch, he said he got 175 feet. He did not have the gain cranked up. He said he thought he could have gone much further. or at least a little bit further had he increased the gain, but the guys that he was demonstrating the product to were good with the 175 feet. I don't know. On the 96 inch, I don't know. You're definitely going to give up some distance with that diameter, but yeah, it still should work, 100, 150 feet or so, I would think.
It'll work.
Maybe 30. I don't know.
And Scott's asked, does the equipment need to be calibrated on a regular basis?
Nope. There is no calibration on this. It's acoustics. So yeah, there is no calibration.
And
Great.
it's the sensor is very durable. It's
Very, yeah. Yeah, these things get abused. And I will say too, if we find a better way to do this firmware wise, we update our website with firmware upgrades, and no charge. You just plug your unit into your laptop or your desktop or whatever you use, and you can download any firmware upgrades if we find a new cool slick thing or a better way to do it.
And I will add that we are working on a phone app where you can do firmware up. Eventually, you'll be able to do firmware updates over your phone attached to the unit via Bluetooth.
Good. One more question. Will signal transfer from dissimilar materials, example, plastic gas riser to a steel service after the curb box?
Yes, it will. Again, most of your sound energy is traveling on the inside of the pipe. Just picture a sine wave kind of bouncing down the pipeline. So yeah, it does. This unit does really not care what material that you're in, frankly. Stiffer stuff bounces a little better for the signal, but the reality is it'll do anything.
And I think to just continue what Brad said, using this device is not the same as waving an electromagnetic detector around. You have to spend some time with it, get to understand how it works in terms of sound waves versus electromagnetic waves. But if you've used an electromagnetic detector, the analogies are very, very close in terms of transference and frequency and all those sorts of things.
And to continue what Mark was just saying, it really is that the steepest learning curve for folks going from an EM locator to this is just understanding what the frequencies do. With your EM locator, higher frequency, better for inductive, lower frequency travels farther, but is more stymied by resistance. Acoustic signals are different. They are not EM. For us, the optimal frequency for penetrating through soil is 50 hertz. However, it is not always the optimal frequency for the given situation you are in geographically, right? There are times when you want a higher frequency, a narrower wavelength to penetrate tree roots, for example. If you are locating a line and you're running just back behind the curb and you come to a catch basin, in lower frequencies, you have longer wavelength, more vibration in the soil, and it can turn that catch basin into basically just a big echo chamber. So understanding that, wow, if I dial my frequency, from 70 hertz to 110 hertz, I make all those issues go away in that particular spot. Same thing for storm sewers, that sort of thing. If they're really close, you can turn those into big echo chambers. The simple fix is just go up in frequency. So there's a little bit of a learning curve, but I mean, I can train somebody as far as on the use of the unit in 10 minutes. But like with EM, learning the different frequencies, how they react to different scenarios and all of that, that takes a little bit of time. I've lived with this thing for 2 years, and frankly, I still learn almost daily when I'm out here in the field. So,
Very good. Very good. I think that's most of the questions. Sudeep, I can confirm that we do not detect the depth of the pipe at this time. That's something that we're going to work on in the future, but we're not there yet. Gus is asking, Brad, would you then use a higher frequency if the pipe is running close to the curb or along the curb?
Generally speaking, yes. When I run my frequency scan and it gives me my three best frequencies, and I look at the graph and kind of see where my responses were, I'm going to, if I know I've got I'm running down the back of a concrete curb, I'm going to lean towards starting at that higher suggested frequency and maybe even 5 or 10 hertz above that, depending on what the response was on the graph. So yes, Gus, that's spot on. You're picking up what I'm putting down, man.
Great. Great.
And Dave, I'm just gonna, Mike Moore, who's one of our guys, made a good point that what people tend to do is if they're moving along longer stretches of pipeline, if they excavate down to create an access point to continue locating, they'll very often just drop a piece of PVC down on that hole and use it as a ongoing access point if they need it in the future. Cap it off.
Yep. Good. Good. Well, we are 4 minutes left to go. If there's any other questions, we're happy to answer them.
And Dave, I'm just gonna comment because we've been asked several times on pipe depth. As Brad kind of intimated, our engineers, myself included, have some interesting ideas how to do pipe depth that might be available in a future firmware update. We're still working on that. It's an interesting technical problem, but we're aware people want it, and we hope to solve that problem. But that's a ways out. I will say we've got a bit of R&D to do on that. What we've done now is just try and make the thing really good at locating. So,
and we've had several questions about scheduling demos, and I would say reach out to Brad. His email's on the presentation, or if you are already engaged with one of our resellers, Eastcom, Green, Subsurface, Batco, in Southwest Valve, they can also schedule a demo for you.
And I've just thrown up, we have a slide we'll just leave up there that has our info email as well as the contact links for our current distributor network. We are, by the way, working to add a couple of other distribution partners that haven't been finalized at the time of this webinar.
Great. Well, thanks everyone again for attending. We appreciate the opportunity to spread the word about SonicFinder 1000, and we hope that we can have you trying it soon.
Yep. Feel free to reach out with any questions or anything.
Thanks, everybody.
Bye now.